Hey guys, how's it going? I hope you have had a wonderful last couple of days. Hopefully it was a little bit relaxing having close to 3 weeks here of spring break. I mean, I'm sure you still had to, sign into your classes and do a couple of assignments here and there, but from what I've heard, there were some nice and easy ones. So I hope you guys had a good time and ready to get back to work here. Don't be alarmed by the length of the video. If you're only looking for one assignment, this is going to be going over both assignments. Please note, if you're in the Wednesday class, I only have one Algebra 2 in the Wednesday class. So you are able to do the second assignment as well for like replacement credit if you like had a 0 earlier in the semester, or maybe you're preparing to not do an assignment in the last couple of weeks of school here. It's kind of like extra credit slash replacement. I mean, you can't go over 100, but maybe you need some more points. Let's get it done. Sketch the graph of each function. So this is going back to our parabola stuff, parent functions all the way back when. So just as a reminder, what we're doing here, we have our parent function here, our x squared, but we have this a is equal to -3, which means it is reflected over the x-axis. So reflect over the x-axis and skinnier by factor of 3. Or you could say it's a vertical stretch, I guess is the fancier way of saying it. I'm not going to do a whole beautiful graph of these. I don't really want to, so I'm just not going to. Making it somewhat reasonable though. Kind of make it skinnier and negative. I don't know. I'm satisfied with that, to be honest. If you really would like to have more specific coordinates, you can, labeling 0, 0, maybe labeling something like, 2. If you plugged in 2, what would happen? 2 times 2 is 4 times 3. You got -12. I don't know, -2, -12. There's some extra coordinates. I don't know. I'm satisfied with this, though. Looking at this guy, very similar in nature, but this time we have a moving to the left 3 units and then moving down 2 units there for our graph. So that means our vertex, our key coordinate, is going to be starting off at 1, 2, 3 down 1, 2 here at -3, -2. And then there's no number in front, so this is just going to go up this time. So sometimes it's good to have at least one other coordinate over here. I kind of recommended that before. If I plugged in 0, what do I get? Plugging in 0, 3 squared, that's 9, -2 is 7. So that means I got 0, 7 on my graph. And just to make it nice and neat, go up. Remember, there's that idea of this axis of symmetry that runs down the center that can help us find some other coordinates. So if it's 3 this way, it is also 3 that way, which means this guy is -6, 7. Don't really need all those coordinates. It's just a quick sketch. Most important for me is that it's to the left 3 and down 2. All right. Over here into factoring. Remember, the idea is you're figuring out the numbers that multiply to -45. But they have to add to +4. Some numbers that multiply to 45, 1 times 45, 3, I almost wrote 2, that doesn't work, 3 times 15, 5 times 9, nothing else works. This guy is positive. I would definitely check out your notes for there if you need a reminder of what that means, but it does mean that the left-hand side here is negative. And so you got -5 plus 9 there is 4. And there you go. That's pretty much the whole answer. B -5 multiplied by B plus 9. Awesome. Problem number 4. This one is very similar, but you have to factor out a monomial first. That's kind of the words for it. There's a 5 that can be factored out of all of them before you even start the problem. Minus 18r plus, oh boy, divided by 10 is 40, divided by 2 more is 20. That's not right. That's not right at all. Just said as 80. Oh my gosh, why did I don't know what happened to my brain there, but it collapsed. After that, we got to figure out what numbers that multiply to 80 and add to negative 18. So that means they're both going to be negative, right? Anyways, multiplying to 80. So 1 times 80, 2 times 43 doesn't work. 4 times 20, 5 times 16, 6 doesn't work, 7 doesn't work, 8 times 10, boom, this is going to be it, both negative. 5, r minus 8, r minus 10. Easy peasy. Number 5, one-step question. Difference of two squares. Difference of two squares. Because this guy's a square, that guy's a square. 3 squared is 9. 2 squared is 4. So 3n minus 2. 3n plus 2. Important concept. Going to show up a lot as you move forward in mathematics. Continuing on. Here we go. Number 6. Solve each equation. It tells you that you can just do whatever you want. I believe I made these all factorable. But I think on number 7, those numbers look crazy. I think I'm gonna use a calculator for those for sure. In our quadratic formula. But I think number 6 is factorable. I don't remember. I clicked some buttons on the computer to make it happen, but you know, that was like 4 days ago now, so I don't remember. We're gonna go ahead and add 6 to both sides. Minus 5a squared minus 5a squared. Here we go. 6a squared minus 5 is a squared plus 9a. 12 and 6 is 18 equal to 0 now. What multiplies to 18 and adds to 9? Honestly, I don't think we have to write anything for that. That's easy enough. 6 and 3. Zero product property. Subtract 6 on both sides. Subtract 3 on both sides. Done. Number 17. The reason why this one's not as easy is because when you move this over here, you don't end up with a number that's nice and neat up front. You get this absolutely awful looking thing of 14 and 47 and 30. And if I did my regular thing, I'd be doing 14 times 30. I get 420, trying to figure out multiplies to 420 and adds to negative 47. And I don't want to do that. That's not part of my game plan right now. So instead, we're going to go ahead and jump to the quadratic formula. A is equal to 14. B is equal to negative 47. C is equal to 30. And then x is equal to negative b, so positive 47, divided by 2 times 14, plus or minus the square root. All this is also over 2 times 14. And we got b squared minus 4ac. And I brought Desmos up ready to go to plug this in, but I think on second thought, I'd rather use Wolfram Alpha, because Wolfram Alpha will give me the exact answer as well as the decimal answer. So I'm just going to type this bad boy into Wolfram Alpha here. And this is really what you should be doing too. This is a good thing to be practicing. You're allowed to use this in those online math classes that you might be having to deal with, and that kind of thing. So plus... and then you got SQRT parentheses. Oh, come on. Come on. Negative 47 squared minus 4 times 14 times 30 and the parentheses divided by 2 times 14. All right. And it turns out this is exactly 5 over 2, which is exactly 2.5. Or it is exactly, let's change this to a minus sign because it is plus or minus that square root looks like, or 6 over 7, which is approximately 0.857 it says there. There you go. So I wrote all that down. That's my recommendation. If you wanted to show more work on it, you could like do 47 squared, write that out, do the individual parts, you know, maybe you're using a different calculator instead of Wolfram Alpha, but good enough for me. Here we go. Let's go on the rate. Find the discriminant of each quadratic equation and then state the number and type of solution. So remember, the discriminant is just the part that's under the square root. This does not say to solve the entire problem, it just wants that, and it wants the number and type of solutions. So go back to your notes for that if you need it, but if D is positive, it's 2 real, D is 0, then it is 1 real solution or 1 double root, and if it's negative, then they're imaginary. So we're going to add 10 to both sides here. We get 7x squared minus 5x plus 3 equals 0. So A is 7, B is -5, C is 3, and therefore D is equal to -5 squared minus 4 times 3 times 7. So you got 25. 12 times 7, what's that going to be? 84? -84. And again, we don't care what the number actually is. 25 minus 84, you might not be able to do it in your head, and it doesn't matter because you should know it's a negative number of some kind. Negative something, which automatically means it is 2 imaginary solutions. I guess it did say find the exact discriminant. I probably should have done that. Fine, I'll actually do it. Subtracting, we got, was that 6459, -59? 2 imaginary solutions. All right. Number 9. This is another one you might have had to go back to your notes, but you have to multiply the top and bottom by the conjugate of the bottom. So the conjugate there, 3 minus 4i divided by 3 minus 4i, and we have to do our whole first, outer, inner, last foiling, maybe even making a little box if that's what you're into. But yeah, 6 times 3 is 18, 6 times -4, -24i, -4 times 3, -12i, -4 times -4. We got 16i squared. And on the bottom, the whole point of this is that you square the first one and you add it to squaring the second one. So don't do any extra work. Don't do any actual foiling on the bottom. And just use the trick. In this one, I squared is -1. So 18 minus 16 is 2. And that's over 25. And then 24 minus 12 is 36. And that's over 25 with an I on it. Always make it 2 different guys, A plus BI form. If you are only doing that first assignment because you're in the Wednesday class and you're not doing the other one, then I'll let you head out of here. Peace out. Have a wonderful weekend, etc. If you are still hanging out with me, though, and moving on to the next assignment, here we go. Let's do it. Assignment number 2. I made this one only 4 questions because I figured that'd be a little bit more fair because you didn't have to, you had a little bit extra math by comparison to your peers who are in the, Wednesday class. Only 4 problems, not too big a deal. Interest questions. Again, I personally think that these guys are important. So let's do it. So Jasmine invests $3,306 in a savings account with a fixed annual interest rate of 9% compounded 12 times per year. What is the account balance after 9 years? So lots of stuff going on here. I want to remind people of those formulas. It is always the new equals the old multiplied by the growth factor. So in this case, our new is what we're looking for. Our old here is 3,306. And then our growth factor that we're looking for here is an APR situation because it's a compounded and it's like 12 times per year. So our growth factor in this case is going to be 1 plus that 0.09, that percentage, over that n of 12 there, raised to the 12th power, and then it's 9 years worth. So we have to do that, all of that, to the 9th power because you're doing it 9 years of time. So boom, we'll plug that in, and honestly that is a straight calculator question. This is where we just use Desmos because Desmos will make it nice and neat for us. So let's do it. Where's my Desmos at? Here we are. We got 3,306 multiplied by parentheses 1 plus 0.09 divided by 12. Raise that up to the 12th, and then we need like brackets around all this. And that is raised to the 9th. Oh, that's an element list. That doesn't work that way. Maybe brackets aren't okay on Desmos. Never mind. There we go. That worked out. That's better. Or you could have used, different calculator, different situation, whatever it is. And because you are doing money, we're gonna round to the nearest second decimal place there. So $7,409.16. Oh, and I didn't write out the formula there. I got ahead of myself. The formula for a growth factor, if you did need it, is going to be 1 plus the percent change divided by 100, all divided by n raised to the n. And that's going to be for 1 year. And we did it 9 times because it's 9 years worth. So you're multiplying it by itself 9 times. Here we go. Yeah, problem number 2. What was the amount of the initial investment? So this time it ends with that number, so we're going to solve for the old. So it's 6234.40 equals the old value multiplied, and that growth factor, let's just do it all in one step. We got 1 plus 0.03 divided by 4 raised to the 4th power, because it's compounded 4 times per year. And then I guess I'll use big parentheses because Wolfram only likes parentheses. And then final answer is going to be this guy divided by this guy. So old equals, get our calculator out. We got 6234.40 divided by, and then 2 parentheses, 1 plus 0.03 divided by 4, and the first parentheses to the 4th power. To the right once, and the parentheses to the 5th power. Oh. And looks like exactly $5,369. There we go. Not too painful. Let's do our graphs here that had all the other information that we were supposed to get done here. So for each function, determine the domain, range, intercepts, and end behavior. So for this situation, again, really want to have your notes out. The notes kind of tell you what you got to do. So domain, all real numbers are allowed to be plugged in here. So we're going to write, you could write the R, you could write the ARN, or my favorite, negative infinity, comma infinity, that interval notation. That's going to be the case for all of these exponential problems. The range is kind of the minimum value up to the maximum value, and that's determined by the shape of the graph. So it's either greater than, less than. In this case, our range, our possible y values, 0 to infinity. The intercepts, it is always 0 comma whatever this guy is in front. So the intercept here is going to be 0 comma 2. I'm going to pause here and remind you that this is a coordinate and this is a range of values. This says all numbers between 0 and infinity, and this one says just the coordinate 0 comma 2. There's a big difference there. Even though they look similar, they're totally different things. Like, these are all a bunch of y values. Annoying little notation. And then for the end behavior, anytime you have a positive like this, we would say as x goes to infinity, f of x also goes to infinity. As x goes to negative infinity, f of x also goes to negative infinity. Or wait, what does it go to? It goes to 0. I'm sorry. What am I saying? It goes to 0 on the left-hand side. What am I saying? Then you gotta sketch a graph of this guy. So if you forgot any of this information up here, though, and this is all sounding foreign to you, I am asking you, pretty please go into your notes. We made all of these beautiful looking graphs. I even prepared it in advance to remind you we did do this stuff. We did do these things. We wrote down the intercept. We kind of drew the picture. Maybe not the range part. Maybe that's not as good. We did a whole example here at the bottom. Anyways, let's finish up this guy, this sketch. So I am not making this crazy neat. I'm just doing a little bit here. We got that 0 comma 2 start, and then we are shooting way up here and going down here because we had the positive. All right, let's do problem number 4. Let's do it. This one's backwards. Exactly the same thing, but backwards. So now I'll determine the graph term, domain, range. Okay, so good news is domain and range are exactly the same. So domain is still negative infinity to infinity, or all real numbers, wherever you're going to write. The range, still 0 to infinity here. The asymptotes. So asymptotes, I thought I deleted that word off of this question. Man. I deleted it off of the third problem, but not the fourth question. I apologize, guys. I thought I double-checked this. You haven't learned the word asymptote yet. If you wanted to know, the answer is y equals 0. And where the function increasing, decreasing, we don't need this information. I am so sorry. Man. What a bummer. End behavior is exactly the same as that previous question. So I'm going to write it down over here. It's as x goes to infinity, f of x also goes to infinity. We know that because as it goes to the right, it goes up. And as x goes to negative infinity, f of x goes to 0 because it's going to that bottom line there. After that, our y-intercept. This guy here is 0, 4, which means for our function f of x equals, we have a 4 right here in front, multiplied by something to the power x. Now remember that something, this is a little bit of thinking here. This guy right here is a growth factor, right? So it's how much you're multiplying by to get to the next value. So we got to figure out what the next coordinate is. And if you notice, it's 8. So if I'm starting at 4 and I end at 8, I'm asking myself, what number when I multiply it by 4 is 8? Well, 2. Easy peasy. There were a few other ways to do that problems. We could have even done it with our logarithms that we haven't quite learned in every single class yet, but I'm going to pause there and let you guys be. I hope you have had a wonderful last couple of weeks and that you're ready to come back to regular old school on Monday. But in the meantime, have a great weekend. Have an awesome Friday. Happy Easter for those celebrating it. Happy Passover for those celebrating that. And just have a good one. Can't wait to see you guys on Wednesday. See you later. Bye-bye.